Hi, 7th grade. This is video 1 of 12.6 permutations and combinations. Before we actually get into the definition of those two words there in our title, we're going to start with some more basics. So I'm going to start by giving you a scenario where I hand you 3 movies, a comedy, a drama, and an action. And you want to figure out what are the possible orders that you can watch these. So you decide to either create a list or a tree diagram, which tend to be more common if it's a math assignment. And you can create a list of outcomes here. So in our tree diagram, if we look over here to the right-hand column, we end up with 1, 2, 3, 4, 5, 6 possible outcomes of watching these 3 movies in different orders. Okay, pretty straightforward, not too many outcomes there, but I have a note here for you. When order matters, and/or, if there are no repeats, which both happen to exist in this example above, the number of possible outcomes is much smaller than when order does not matter, or there are repeats. So we're going to revisit this scenario again. And let's say instead of me just physically handing you 3 different types of movies, I'm asking, if we watch all the comedies, all the actions, all the dramas, and you only get to choose 3, how many ways can we watch them? So here, order does not matter, and as well as repeats are okay. So I could watch 3 comedies. I could watch two dramas and an action. So if I look at all my possible outcomes in this scenario, I have 3 for my first, 3 for my second, 3 for my third, and in this tree diagram I went down instead of left to right. So across the bottom here, I have 27 outcomes. Okay, so when you add more possibilities, your number's going to grow very dramatically. So if you can imagine, some of these numbers of outcomes can be pretty large, especially if you start getting into some very specific information. So that's why something exists called the counting principle. The counting principle is a way to find the total number of ways to make multiple selections, and you do so by multiplying the number of ways each selection individually can occur. So let's do this quick example here, and then we'll bounce back up through the movies. Let's say we want to choose new outfits for the summer, and we buy 5 shirts and 8 shorts. So how many possible outfits do we have that we can show off over summer break? Well, if we have 5 options of shirts and 8 options of shorts, we just multiply 5 times 8, so there are 40 possible outfits. Now that's assuming all the shirts and all the shorts would match, but we're not going to do what ifs to ourselves. We'd have 40 possible outfits to show off. Okay, so if we go back up here in the first example, here we have 3 options for our first movie. Remember, in this example, I physically handed you one of each type of movie. So you can choose one of the 3 options for your first choice, then you have 2 options remaining for your second choice, and then just the 1 option remaining for your third choice. You multiply all 3 of those together, 3 times 2 times 1, you have 6 outcomes. Okay, when I opened up that example more and said you can have repeats, here we have 3 options for our first, 3 options for our second, and 3 options for our third movies, for a total of 27 outcomes. So the counting principle definitely comes in handy whenever you're asked to find the total of outcomes, but if you're asked to list them out, then that's when you'd have to resort to a tree diagram or a list. Okay. All right, so let's take a look at Got It 1. A pizza shop offers 8 veggie toppings and 6 meat toppings. How many different pizzas can you order? Well, if we have 8 veggies and 6 meats, those are our 2 options. We multiply those 2 numbers together to get 48 different pizzas. Pretty straightforward. Don't forget to label. Okay, now the extra example gets a little more complex, and the reason why I added this is these are types of problems that you'll see in the future that your book doesn't directly address, so I wanted to do a couple of these with you. So you are creating a new passcode that begins with 2 one-digit numbers followed by 3 letters. How many possible passcodes could you choose if? So our first example we're going to look at is with repeats, and then the second one will be without repeats. Okay, now regardless, there are 10 options of one-digit numbers, and there are 26 options of letters in the alphabet. So if we have a passcode created by 2 numbers and 3 letters, then I'm basically setting up 2 numbers, 3 letters. 2 numbers, 3 letters. But our two scenarios here, example part A and example part B, look different. And the reason for that is in the first one, we're allowing repeats. If we choose 10 numbers for the first, if we choose out of 10 numbers, because the digits are 0 through 9, if we choose one of the 10 digits for the first, we can repeat and choose that same one. So we still have 10 options for the second. Same with the letters. We have 26 options, 26 options, 26 options. Okay, multiply all those numbers, and that's how many passcodes we can have. But in example part B, we now cannot have repeats. So once we choose a digit for our first entry of our passcode, it's no longer available for our second digit. So that's why we dropped from 10 to 9. And then when we go to letters, we have 26 letter options. We've used one, we now only have 25. We used another one, now we only have 24. We multiply all those outcomes together, and we still get a rather large number of passcodes. However, if you want to make it as difficult as you can for anybody to crack your code, you want to always offer yourself the opportunity of repeats, because that means there's more possibilities that that person would have to try to crack in order to get into your passcode. So the last definition for this video, and then we're going to take a break, is permutation. Permutation is an arrangement of objects in a specific order. So an example could be the permutations of letters A, B, and C. We've basically been doing this above. If we have A, B, C, A, C, B, and so on, even though we're using the same 3 letters over and over again, it's telling us that the order matters. So permutations are anytime you're actually trying to find the number of outcomes when order matters, you would use that phrasing. How many permutations of the letters A, B, and C? If order did not matter, there'd only be one outcome here, because all of these would represent the same type of outcome if order did not matter. So it'd be a pretty boring example to go through. Okay. And then in factorial, this goes along with permutation. So it's officially our last definition here for video 1. The n factorial is the product of the integers from n down to 1. So this is the exclamation point. And I can't quite remember if we ended up including this in our lesson last year or not for probability. But we're not shouting math at each other. It's actually a math symbol. So the best way to show you how it works here is got it do. So a swimming pool has 8 lanes. And how many ways can 8 swimmers be assigned lanes for a race? Well, order matters when you're assigning lanes. That means you can't have repeats. If you have 8 lanes and 8 swimmers, once you choose one of those swimmers, you only have 7 to choose from for this next lane. 6, 5, 4, 3, 2, 1. So we can either think of it as this is a permutation like we did in the last example with the passcodes, or you can think of it as, well, this means 8 factorial. Anytime you're trying to find a specific number in a specific order, it's factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Many calculators, scientific and graphing, will have this symbol. I unfortunately do not have a scientific calculator at my house. I only have this graphing calculator, but just to kind of show you, there it is. Okay, so I could say 8 factorial equals, and it's much faster than 8 all the way down, and technically typing the times 1 wouldn't matter, but okay, so that's how factorial works. So if you are interested and you have a graphing or scientific calculator at home, you can search up on Google, even YouTube videos to help you. It'll show you how to use your calculator. The scientific would be a little bit easier than the buttons I just pushed for my graphing calculator, but could be useful. Okay, so that's where we're going to stop for now. The next video, we're going to take permutations to another level, and then also look at combinations.